Okay, today I want to talk about section 8.5, which is about two parts: equations that contain absolute value Let me get a pen. So we've done linear equations, linear inequalities, and then functions, linear and nonlinear. Now we're getting to equations and inequalities that contain absolute value. The first part is about equations with absolute value. And just to remind you, the absolute value of a number is its distance from zero on the number line. The absolute value of a number is its distance, so it has to be positive because distances cannot be negative, from zero on the number line. So for instance, the absolute value of 3 is 3 because 3 is 3 units away from 0, and the absolute value of negative 3 is also 3 because negative 3 is 3 units away from 0 on the number line. Okay. So the absolute value of 0 is 0 units away from itself. So if the number is negative, its absolute value is positive. If the number is positive, its absolute value is positive. If the number is 0, its absolute value is 0. So now if we say solve for x and absolute value of x equals 4. So basically what we're doing, we're finding all real numbers that have a distance of 0, the distance of 4 from 0 on the number line. We know that absolute value of negative 4 is 4 and absolute value of 4 is 4. So the numbers that are 4 units away from 0 on the number line are 4 and negative 4. So if absolute value of x equals 4, that means x equals plus or minus 4. In general, if absolute value of x equals c, where c is positive, like whether it's 4, 4.5, 10, whatever it is, as long as it's positive, then x is plus or minus c. Because absolute value of c is c, and absolute value of negative c is also c. Now, if absolute value of x equals 0, if the distance from x to 0 is 0, then x itself must be 0. And if the distance is negative, if c is negative, then there's no solution. It doesn't make sense for the distance to be negative. Okay? It does not make any sense. Let's look at some examples. So we're going to start with page 664, number 20 from your text. Solve for x and absolute value of x equals 90. Again, this is rule number 1. So x has to be plus or minus 90 because absolute value of 90 is 90 and absolute value of negative 90 is also 90. Okay. What if absolute value of x equals negative 90? This is rule number 3. That means we have no solution. And if it's negative absolute value of x equals negative 90. So we want to isolate the absolute value first by dividing by negative 1. And that takes me back to the previous example, x equals plus or minus 90. Because now negative 90 becomes positive 90. Let's go to 24, page 664. Number 24, page 664. Absolute value of 5x minus 3 equals 22. Again, the absolute value is isolated, and c, this is c, which is positive, but instead of x inside the absolute value, 5x minus 3 is inside. So we're looking for the distance. Absolute value is distance from 0. Between 5x minus 3 and 0 is 22. So 5x minus 3 could be either 22 or negative 22. And I'm splitting it up so I can solve the two equations because x is not isolated. So add the 3. So 5x is 25. Divide the 5. X is 5. Add the 3, 5x is negative 19, negative 19 over 5. So we have two solutions. And let's check them so we can see that does make sense. If you check the 5, and up there, absolute value of 5 times 5 minus 3 equals 25 minus 3, which is 22. If you check negative 19 over 5, 5 times negative 19 over 5 minus 3 in absolute value, the 5's cancel out, negative 19 minus 3, negative 22, in absolute value equals 22. So they do, as expected, they do check. Okay. Here's another example. Absolute value of 2 minus x plus 3 equals 5. So before we do any rules, we gotta isolate the absolute value by subtracting the 3. So we got 2. And now since this is positive, 2 minus x is 2. Or 2 minus x is negative 2. Subtract the 2. Negative x is 0. Divide by negative 1. X is 0, or subtract the 2, negative x is negative 4, x is 4. So we got two solutions. And if I have absolute value of x minus 21 is negative 8, then it's no solution, because when the absolute value is isolated, you cannot have a negative there because distance can never ever equals a negative number. Absolute value of 3x plus 2 over 6 equals 0. Now for this one, we know the rule that says if absolute value of anything, could be anything, is 0, then whatever is there has to equal 0. So whatever is there has to equal 0. And we get a linear equation to solve. So we're going to get rid of the fraction by timesing by 6. 3x plus 2, 0 times anything is 0. Subtract the 2. And there is only one solution in this case, which is negative 2/3. Which is negative 2/3. Now, now we know that absolute value of 5 is 5 and absolute value of negative 5 is 5. Just for any two opposites, they have the same distance from 0. So if I say two numbers have same absolute value, if same means equal absolute value, meaning the absolute values are equal. So Like could be 5 and -5, they have the same absolute value. It could be 5 and 5, they have the same absolute value. So the numbers could be equal if they are equal, same number, or they're opposites, like 5 and -5, or they are opposites. So for example, if absolute value of A equals absolute value of B, two numbers A and B have same absolute value, that means they're equal, like A equals B, or they're opposites. A is the opposite of B, or B equals -A. It doesn't matter. Okay, so if you have two absolute values, one on either side of the equal sign, and you want to drop them, then you're going to have two equations. When you drop them, you get the first equation, and the second one, you're going to make one of the sides negative. Okay, and here is an example. How do we solve the equation 3x plus 1 in absolute value equals x minus 5 in absolute value? Again, these have the same absolute value, so they could equal. By dropping the absolute values, we get the first equation, or they could be opposites. So we keep the left side as is, we don't change it, and then we do the opposite of x minus 5, which is actually negative x plus 5, if you distribute the negative. So let's solve the first equation first. So 3x minus x is 2x. Drop the 1, move the 1 over. 2x is -6. Divide the 2, x is -3. Add the x. 4x plus 1 equals 5. Move the 1 over. That gives me a 4. Divide the 4. We get two solutions. Okay, now, so this ends equations and absolute value. Now we're going to do inequalities and absolute value. So that's part 2, inequalities and absolute value. So I have a handout about this section. Actually, it's on D2L under handouts. This is for the inequalities. You can see that. Let me zoom in. So check that out. And there's a couple of examples about this part, okay? All right. So what if the distance from 0 to x is less than 3? What are we looking at? Well, if you look at the number line, where does that take us to? Well, it cannot be 4. X cannot be 4 because 4 is more than 3 units away. It cannot be -4 either because, again, -4 is 4 units away, which is not less than. So this is not the right way. So it could be 3, no, because it doesn't say equal. It could be 2, yes, -1. So it's actually everything between -3 and 3 would give me a distance less than 3, not including these values because we don't have the equal sign. So if absolute value of x is less than 3, then how do we write this? This is an AND compound inequality, so -3 is less than x and x is less than 3. So as a general rule, if absolute value of x is less than c, as long as c is positive, then again -c is less than x is less than c. And if you put the equal sign, these all become equal. Same thing here, c greater than 0. Okay, and it doesn't have to be x, could be x plus 1 inside the absolute value, x minus 1, and so on. So for example, number 58, page 665. 58, page 665. Absolute value of x minus 8 is less or equal to 12. Again, first we gotta make sure the absolute value is isolated. Then we look at the inequality. This means it's gonna be and later on you will see if it's greater than, it's gonna mean or. So the absolute value is less than 12, so it's gonna be between negative 12 and 12. So we drop the absolute value. When we drop the absolute value, we get the inequality, this one, and then we put the negative 12 on this side, less or equal again. And we learned how to solve that. So isolate the x by adding the 8. It's negative 4. And always when it's an inequality, we want to graph and put it in interval notation. So let's do 5, 10, 15, that's 20. And if this is negative 5, so negative 4 is about there. So anything between negative 4 and 20, including them because of the equal sign. And then the interval notation. Here's another example. Number 60, page 665. Absolute value of 4 minus 3x is less or equal to 13. Again, absolute value is isolated, it's less than, so we drop the absolute value to get one part, and then we put the negative with less or equal on this side. Subtract the 4 to isolate the x in the middle. Negative 17 is less or equal to negative 3x, less or equal to 9. Divide by negative 3. The negatives cancel out, 17 over 3, or 5 2/3, and that's x, and that's now what I did, I kept the inequality. That's a big mistake because I'm dividing by negative 3, so it should be greater or equal. Greater or equal. Must flip the inequality because we're dividing by a negative. So if I then graph it, negative 3, 5 2/3, and everything in between with a bracket because of the equal sign, and again with the interval, same thing. Now what if it was greater than? What if we have absolute value of x is greater than 3? So if you look at the number line, definitely it's not going to be negative 2 or negative 1 or 0. It's going to be 4, 5, 6, and everything in between the decimals. So we're going this way, and it could be negative 4, negative 5, and so on, because its distance from 0 is more than 3. So that's why when you have absolute value and greater than, it switches into or. You can see why. So to get the or statement, you put an or, and then you drop the absolute value to get this part, x is greater than 3. To get that part, you flip the inequality and make it negative 3, and that's going to give you this part. So you drop the absolute value, you get this part. You flip the inequality and make it negative 3 to get the left part, and that's going to give me negative infinity to negative 3 or 3 to infinity. So as a general rule, if absolute value of x is greater than c, where c is positive, then you drop the absolute value to get this part, or you flip the inequality and make c negative. And same thing with the equal sign. Okay? So let's look at 66, page 665. Absolute value of x plus 5 is greater or equal to 7. So the absolute value is isolated, it's greater or equal, so we drop the absolute value and we put an or, and then we keep the left side the same, flip the inequality and make 7 negative. minus 5, x is less or equal to negative 12, or x is greater or equal to 2, negative 12, and 2, less or equal to negative 12, and greater or equal to 2. And then the intervals, negative infinity to negative 12, union 2 to infinity. Now I want to do another example, which is not from the book. Absolute value of 1/2 x minus 3 minus 4 is less than 2. So since we have a minus 4 next to the absolute value, we gotta add that to isolate it. Is less than 6. Absolute value and less than. So that's an and. So we drop the absolute value, we get this portion, we do negative 6 less than on this side. We add the 3. Negative 3 is less than 1/2 x is less than 9 times by 2. Negative 6 is less than x, which is less than 18. And you can graph it. Let's say this is 18, this is negative 6, everything in between. And there's the interval. Now, what if we have something like number 62, page 665? Absolute value of 3x plus 2 is less or equal to negative 3. Now, when the absolute value is isolated, we cannot have a negative there. So we have to use common sense. No rules can be used here. No, use common sense. Common sense says this is always positive or 0. It cannot be less than a negative number, okay? A positive, it cannot be less than a negative number. Why? If you put any number in there for x, whether it's positive, negative, or 0, you times it by 3, add it 2. Once you do absolute value, it's going to give you a positive. For this inequality to be true, this has to be less than or equal to negative 3, which is never true. So it means no solution. Now, if we flip this, if I do another example, and make it greater or equal to negative 3. Well, this is positive. It's always greater than a negative number. A positive is always greater than a negative number. The solutions, anything will work, all real numbers. And another special case, if absolute value of x minus 5 over 10 is less or equal to 0. We know an absolute value cannot be less than 0, but it can equal 0, right? So x minus 5 over 10, the only time this is going to be true is when it equals 0, times by 10. X minus 5 is 0, so x, that's the only number that's going to make it work, because 5 minus 5 is 0, 0 over 10 is 0. If you put anything else, it's going to give you like positive, like 3 or 5 or 7, which is never going to be less than 0. And I think that's it for 8.5.